time with me or any question about the project? Okay. Today we are going to talk about this cantilever retaining wall, and after that, if we have time, we are going to model this masonry wall. So, I modeled this one a little bit simpler than the model we have in the project. So, if you are going to model, if you can model this one, I'm pretty sure you can model, that the retaining wall also. So, we consider this problem as a 2D model. So, when you want to start the model and creating the part, instead of using 3D, we use the 2D planar space. So I consider this as void, deformable shell, and for the approximate size, we have 3 meters, so I consider just 100. And draw a rectangle by these tools and add dimension. And now, as you see,
say you make that field smaller apart. Is there a field for that?
no. It doesn't affect. We just consider the approximate size for having that mesh. If you want to, draw something and you can find it with that grid, it's easier to, use that. But if your grid or something like anything you draw is out of that range, it doesn't matter. So, as you see here, we have this pipe. We have this retaining wall, so we should remove that part from the model. And of course, we don't have soil here, so we should remove that part too. And we use that create cut extrude in 3D model, the solid model, so we are going to use it in, we can use it in 2D planner also. So click on that one and just draw the section you want to cut. I just draw something, and after that, let's just first draw the that part. So the height is 10 meters and thickness. And when you click on done, you cut that area for the pipe.
You turn the lights off in the front?
Yeah. I don't think it's on.
Oh, never mind. No, that's cool. Oh, nice.
And the next cut is a part that we might have soil, so just draw a rectangle and after that. And dimension 6 feet. So okay. And now in the next part we define the wall, the concrete wall. In assembly, we just assemble these two parts, and between these concrete wall and soil, define the interaction. We should use the partition because we want to apply the load here. It's like the assembly project we are going to have. We should partition this part to have this line to select and add the pressure load. And of course, if in that problem you have two different soils, you should have partitioning for two different layers. I just partition this one, and of course for the mesh you need those partitions. So we click on tools partition edge, face, sketch, and you go to the sketch environment, and after that you will draw the line like this for partitioning. When I go to the meshing module, you see that this partition helps us to, have the more precise mesh and the mesh we want for the model. Of course, you have two different layers, so you should have a partition like this for dividing those layers. Another sketch, another partition. One piece here. Another one here. And another one we have here for the load, but we don't know the position, so we just click on this constructed line, define a construction line, and after that we add the dimension like this. 6 meters, so 6 here. And now we draw the line to have this partition also. Okay? So after you put them down, you have different parts in a part you define. Okay, now you can, if you want to apply any specific property to the part of the model, you can apply it right now. Before partitioning, because in that problem we have two different soil, if you don't partition it, you cannot select each part and apply the property of that soil. Right, so you should partition first, and after that you can select that part and that part of the section, and after that you can apply the property. And another part is concrete wall. Just retaining wall. We have the foam level and approximate size 10 meters. Go back to the part to define the soil and define another partition here when we want to apply. We don't need that here, but in that problem you need that because this those two layers is divided here in this location. So you should have another partition here and select these two soils. And you need to partition the retaining wall at this position also. It was, I think, 12 meters, so you have 5 meters here and 7 meters here in the project, so you should do the partitioning for the wall also. So it stands for the part module, so we go to the property and define the property of the material, and after that we assign it to these parts. So, first material is soil. So we have, of course, density, because we want to consider the gravity of the wall and soil, so we should define the density. And after that, we define the gravitation load, and the software calculate and consider gravity for the model. Density in general, you can find density. 600.
I knew
For
it
defining
actually.
elasticity
When I
and
started
elastic
working
part
at
of the
HP.
material, click on elasticity elastic and put the Young modulus and Poisson's ratio is 23 kilopascal. So 26, right? Because our unit is Pascal. And more column plasticity, right, in that part. So just clicking more column plasticity, you have friction angle, and you have this dilation angle. I think in problem statement I didn't mention that this dilation angle, so you can consider it 0.1 for this dilation angle, okay? So we have this C, we have friction angle 28 degrees, so we put 28 here, and for dilation angle, as I told you, consider it 0.1. And in cohesion, you can define the cohesion property of the material. So we have here C 5 kilopascal, so here we consider 500, 5,000, and absolute plastic strain is 2. And that's the property of the soil. Okay, so you have two different soils, you should define two different material property and assign it to two different parts. Next one is concrete. We just consider concrete as elastic, but we should define the density to consider the the weight of the concrete in a model. And the density for the concrete 2,400. For the mechanical elasticity elastic, we have the Young-Lewis and Poisson ratio, so 0.0567. And we define the property. Now we create a section, and after that we apply. Because we want to see the model in 3D, we draw it in 2D, but the software has ability to, has this ability to exclude the geometry. If you consider it as a plane strain, and after that you can see it in 3D. So you can, for this section, you use solid homogeneous because we want to see it as a 3D, right? So here for the, we have soil section. Solid homogeneous, select soil material, click on OK. And we have concrete section. Solid homogeneous, concrete. Okay. And now we assign this section to the model. So select this one. Concrete section. This is the concrete wall. And if you go to the soil part, you select all the, first of all, click on this one, select all part of the material. Here you have two different soil layers. So first of all, if you select this one, apply the soil one, and soil one to this part, to upper part, and that soil to the part. Click on OK, click on soil section, and click on OK. Now we define the properties. Of course, when you see the green color, it means that everything is good. So assembly, this is the part we are going to assemble this wall, soil and wall. So here you click on soil and just insert the soil to the assembly. Click on OK, and after that, click on part retaining wall. Click on auto offset from other instances to have it here, and after that you can move by clicking on this one, translate instance. So select the wall, done, and select the corner of the wall, and select here. Now the wall is assembled in the right place. Click and this is assembly. For this step, just consider that static general like always, but for the implementation, we use 0.1, and for the minimum, we just consider actually a bigger minimum, right? So the software can divide those steps to get the convergence for this problem, because they have less speed in the model, so it's good to have a small number for this one. And okay, and these are the other properties. These are the other options you can have for the for these different steps in our analysis. For example, we can force software to just use the symmetric matrix when it's going to storage the matrix. In a finite element analysis, you can use the symmetric matrix, so it's a little bit tough to get the convergence, but you can use the default solver, the software goes and use symmetric, and if you see that the model is not converging, or the analysis is not converging at this step, it just changes it to unsymmetric. We can put it on unsymmetric at the start, and the software, you don't force the software to use the symmetric matrix. And these are the part, the load, ramp linear overstep. It means that during the whole step, you apply the load. So at first you have the no load, and after that, by a ramp, like the ramp function, you apply the load. You have that pressure load and gravity load. So click on OK, and we define the step. This is the place you can define the other outputs, because we are going to define a contact between the wall and soil. So the software, as a default goes and active the different outputs like the sleep and things like that. I will show you after we analyze the wall. And you can define another output like those examples we saw to getting the moment and shear. I think it's a part of the project to get that shear and moment of the wall. So you can select those. First of all, you active the active that part to software store all the output for the shear, force, and bending moment. And after that, you define a path like before we define it for a beam. You can select the nodes, and after that, get the output for those nodes for shear. So interaction. Here we are going to define the interaction. We have two interactions. For the tangential behavior between soil and wall, we consider this friction coefficient, but we should consider the normal contact also. So here we have, this is the place you can define the interaction. Click on here, and this is the interaction properties, contact, we use contact, and mechanical tangential behavior. Use penalty method, and the friction coefficient here is 0.3544. So that's for the tangential behavior, and normal behavior, you use just this hard contact. Just accept the default of the software. And this part of the property is that when you have the contact with a normal behavior, if you have two surfaces that they are in contact, and after kind of load, these two elements, these two parts want to separate. If you didn't active this part, you cannot, this model, you cannot separate those elements. But you have active this part, you check this part, it means that you allow the separation after you have a contact. So this is really good for us, because we know that maybe in a valve, first of all, we have a contact because of that load, but after deformation,